Hello everyone. A very good morning, good afternoon and good evening to one and all present here. Welcome to Texila e-conference knowledge series. Thank you for joining today's webinar session. My name is Divya Bhupati and I am the SEO analyst at Texila e-conference. Texila e-conference is the leader in organizing online conferences and has been helping entrepreneurs, marketers and professionals achieve their goals. Texila e-conference being an information hub has networked 300 plus international speakers from top brands and shared abundant knowledge to people across the globe. It has hosted EV conferences from 2014 and has inspired people to exchange information on a virtual platform. Today, we are going to learn about how to build real-world products using machine learning, presented by Mr. Rudradeb Mitra, author of Creating Value with Artificial Intelligence. Rudradeb is a global entrepreneur, having built and scaled startups globally, including in USA and UK. He is also a product mentor of Google Launchpad, MIT Enterprise, and Founder Institute. He has been invited to speak at around 50 events from 15 countries. Recently, he published his first book on artificial intelligence titled Creating Value with Artificial Intelligence. Before we get started, I want to share a few operating systems instructions to all the participants. Hi participants, please check your audio settings to make sure the presentation is audible. If you have any questions during the presentation, please type them in the chat box. You can also click the raise hand button at the top so that the presenter will get an alert. Now, without further delay, we will join the session with Mr. Rudradeb. Hi Rudradeb, welcome to Texila e-conference knowledge series. It's a pleasure to have you here.
Thanks a lot for the introduction and for asking me to speak to you guys, to share my knowledge and experience. So I think it would be, I will just continue speaking and then you guys can type your questions if you have. I would perhaps take those questions at the end of the session because it would be just, it would be easier in that way. But if someone of you have a really pressing question, please raise your voice rather than, I'm not going to read the chat, so I have my full screen. So you can speak, interrupt me if you really have to have something really pressing. Otherwise, I'll just type your questions on the right-hand side and I'll answer them. Okay, cool, guys. So I think the reason I want to talk about this topic, and the reason that I've been speaking about this particular topic in different parts of the world is I see there's a lot of interest, a lot of young students as well as young audience who want to go into machine learning and AI. And they do all of these courses that are available online. Andrew and G course is one of the most popular one. But even after doing the course, what I see that they lack is how can I apply that kind of knowledge, machine learning or the coding knowledge into building real world products. So I want to talk about that part. I don't want to go into an aspect of the mathematics, or I don't want to teach you how to code. I presume most of you have already that knowledge or are trying to gain that knowledge. So let me, so as I said, that the focus of today's talk is basically how to build AI products for user adoption. And tomorrow there will be another session where I will be talking about how do you overcome the challenges with data development and user adoption. So, and all that I'm going to say is from my personal experience. So this is not I didn't do it's not a study of third party or like sources from other places. So this is all what I'm going to say is my experience and is my opinion. So feel free to disagree or feel free to kind of object if you find that, I'm saying something wrong. So I have this picture of Segway, and I think a lot of you guys perhaps have known about this product. And the reason a lot of you would be thinking what Segway has to do with AI or machine learning, well, almost nothing. But I tell this story of Segway because Segway first came in 2001 and 2002. And when it was launched, there was even the best and the smartest minds in the world, including Steve Jobs and Jeff Bezos. They said that this is going to change the world. They said that tomorrow, in 5 to 10 years, it will be everywhere that people will be using Segway. It will be even bigger than the internet. It's almost 18 years now, and Segway, we all know what Segway is. And this is a key problem that a lot of technical people, they overvalue a technology and think that the technology is going to change the world well, the majority of the people don't even kind of see the reason of using a technology. And Segway is one of those cases. I mean, why would someone start using a Segway when, you can just walk, or the cost of Segway is too high? So again, whose problem are we solving? So I use the word value, and that's a key thing that the book that I wrote also is creating value. So whatever we are going to build, if we are trying to build a product for a real world, for solving people, it's a value that matters the most. So the focus has to be around value creation. And so that's the whole point of I keep on stressing that the focus is value, not just building a product for the sake of building a product. Now, I would, of course, then a natural question is that if you are sitting and you say, okay, I want to build an AI, can AI create a value? Like, can machine learning? Of course, most of you know the difference between AI and machine learning, but just to repeat that AI is a set of bigger algorithms. So AI would have multiple algorithms, and machine learning is just one kind of algorithms which is trying to understand patterns in the data, analyzing those patterns, and trying to do either prediction, trying to predict a few things, or trying to find anomalies. So that's the basic idea of machine learning, right? So I had worked on different AI algorithms. So machine learning is just one aspect, one of the algorithms I have worked on. But I have worked on planning algorithms, I've worked on regression, I've worked on case-based reasoning. I have even worked on sometime in genetic algorithms. So now when we talk about why there is so much of machine learning is because of the huge amount of data that has been generated over the last 5 years or so, the machine learning ended up being the most powerful algorithm of AI, at least in the current moment. And so when you look at that, we would think about, where are those values, and how can AI and machine learning, if I want to build a product for people that people will adopt, where should I look for those problems? And I say that the starting point, and a lot of young people, when I talk to them, even yesterday I was talking to a group of people I'm now in Warsaw, where they were like worried about the future of AI and like how jobs will be gone and go away. And I say, well, it's what you have to really look at is where are the existing processes, and where are humans good at, and what are humans not good at, and what are machines good at, or what can machine learning can do, and what machine learning is not good at. And then once you identify those positives and negatives, then you can identify where are those problems that you want to solve with. In this case, I have kind of listed some of those aspects of good strengths and weaknesses of human and machine, and I say that humans are good at emotional intelligence, creativity, intuitive power, but we are bad at if we have to analyze large amounts of data. But on the other hand side, machines are very good at if they're analyzing fast, and there is a data which is distributed. So when we look at a problem, and if we have to solve a problem that, for example, have these criteria, that's a criteria that I came across. It look at a problem that has a distributed data. The data is distributed. What that means, the data is distributed means that you are talking about a data not from only one source. Let me give an example. Like if I have to ask you, can you predict your energy consumption in a month time? Most of you will not be able to do the prediction, just because for that you need a data source from not only knowing your patterns, that how you consume electricity, but also you need to know the weather data, because the weather data will have an impact on how your consumption would be. So when you look at that kind of information, that okay, it's not just about the data about one source. So you're talking about analyzing data from multiple sources. So that's one of the key criteria of using machine learning. The second criteria is highly quantifiable data. So many problems in the world are not necessarily be quantified in a format of data. We cannot quantify emotional intelligence. We cannot quantify intuitions, but we can quantify in an image what are those objects are in the image, or we can quantify things like what would be a voice. Let's say that what are we talking about? So or what kind of patterns are there in our behavior or in an e-commerce website. So there are a lot of quantifiable patterns are in the data. So that's where we would go and look at those problems where there is distributed data, quantifiable pattern. The third criteria that I also see, and this is something I keep on seeing a lot of people talking about, they're we are trying to build something that has recognizing cats and dogs in an image, or for that matter, autonomous cars is a great example. And I think it's actually no point of building solutions which is recognizing cats and dogs in an image or an autonomous car, because the human error in those systems is not that high. I mean, humans are not, I mean, I know there are accidents, but it's not like humans are going and killing people like a very high, the error rate is quite low. To achieve humans, to make machines replace humans for those jobs, often the machines have to have like a 99 to 100% accuracy. Like speech recognition is another use case of that. We are very good at recognizing speech. We are good at understanding what people are saying. We don't need a machine to recognize a speech for us. I understand there are cases of scale, like when it comes to large scale, then yes. But normally, when we are thinking of building a product or solving a problem, we should focus on problems which requires a high human error. And then the fourth criteria is you can collect large amount of data from that. And there is a low to medium intuitive pattern. So large amount of data, if you don't have a large amount of data or you cannot collect that data, then of course you are not able to build those systems, at least using machine learning. So to me, these are the 5 criteria that I always say that if you are trying to build a product using machine learning for a real world, focus if all of those 5 are satisfied or not. And if these are satisfied, then go and try to see how can you, next step is how do you build those systems. So I try to explain these steps of actually moving to, once those criteria you have, how do you actually build those systems through 3 use cases. And all the 3 use cases are something that a couple of them I'm working on now, and one of them is I have worked before. I built a company on that. So the first is a clean energy sector. So let me first, I'll skip this slide. I'll come back to this a bit later, that what are the 5 steps of building. But the first step so when you have to build a product, the first step that I say is define the use case. So you have to really know what are you trying to do. What is, let's say, not a pure input output, but what are you trying to define the use case. And in our case, what we want to do is the use case is that typically when people are trying to go solar and install solar panels in their rooftop, the natural process is that they invite someone to come to their home who goes to their roof, analyzes the rooftop area, and gives a report. Now that's a very old-fashioned way of doing things, and the error of that is quite high, because for a person who wants to move solar, he has to spend money, time to have someone come to their home, and it gets a static report. So it is a high human error. The data is actually, there's a large amount of data, because what we can, instead of using someone going to the roof, we can actually use satellite images. So that's the next process. I say that once you identify a use case, the next thing that you need to think is, how do you want to solve the problem? And intuitive step, I call the step as called intuitive thinking, where what you do is you see that there is already a list of patterns out there, and there are the satellite images. So instead, why can't we use the satellite images out there to identify the rooftops edges, or identify the area of the rooftop, and from there onwards, the person can actually in a minute or 2 minutes get an idea of how much solar power energy that his rooftop has. And that's actually an image from India. So we are building the system in India. The third step is to identify the quantifiable patterns. So in this case, as I said, there is an image of solar, and in each of the image, there is certain quantifiable pattern. Because in image, everything has a pattern. So there's a pattern of the rooftop, there's a pattern of the edges of the rooftop, there's a pattern in the obstacles in the rooftop. And that's what we want to identify through the quantifiable patterns in an image. And then the fourth step is identify the best fit algorithm. Perhaps you guys know about CNN. I will not go into too much details, but we are using CNN. But we are actually using a more refined version of CNN, which is mask RCNN, which is semantic segmentation, or something called UNIT. So we are using 2 different algorithms. But overall, it's a part of the CNN. CNN is basically for image analysis, and it's based on identifying the edges of an object in an image. So the idea here that we are trying to is based on the image that we have, that we want to identify the edges of the rooftop in the satellite image. and then based on that, once we identify that, we can easily calculate the area of the rooftop. But the problem is, of course, we know all of those steps. So the first step is, okay, we get to know that what is the problem we are solving. The second is intuitively what makes sense, that how can we solve the problem. The third step is identify the quantifiable patterns which are in the images. The fourth is finding the algorithm. The fifth is gathering the data. Now that's the biggest challenge, and most of the machine learning problems that when we talk about, that is the data problem, we often say. But interestingly, I talk that gathering data to be the fifth step. Here, a lot of companies make a mistake that they often try to, like I was in Kuwait like a few days ago, and I was in a bank, and they said, hey, tell me, we have this data, what can we do? And I said that that's a wrong question to ask. Your first step is not tell me, showing data and tell me what can you do with the data. The first step should be what is the problem you want to solve, rather than focus on the data. The actual gathering the data or about talking about data should be the last step. That you think about how do we gather the data. So in our case, since we don't have the data, no one has the data. It's not like having some cats and dogs images. We have to annotate our own data. So what are we doing now? If you could see the screen, that we are actually have a human. I cannot show the video. There's actually a short video. Anyway, the point that you would perhaps be able to guess is that someone is actually tagging the rooftop edges. And he's a human coming there and tagging that. So we are using a community to kind of create those edges. And like you can see some of the results of what we end up having, that once we tag those rooftop images, we ended up having these kind of masked images or even the obstacles. And then we run the model on the unit, and this is the kind of results that we already have got. So the white area is the rooftop area. So you can see that the black area is outside the roof. So we just want to identify the rooftop. So we are using like a masking. So this is being masked image. So you can see that actually our prediction is quite close to the target. Although we have only like 400 or 500 images that we are using for now. So that's the first product that we are building. I'm involved with building using machine learning, and this has a huge value for the society. The next use case is a company that I had in Belgium, and what we wanted to do is we wanted to improve. Well, there were two directions. One thing is we wanted to make drivers better drivers. We make people drive better. And the second thing is to identify the good drivers and maybe reduce the insurance premium for the good drivers. Because normally most of us end up being who are good drivers. Most of us are good drivers. We end up paying very high insurance premium because there are some bad drivers. And there is no way for insurance companies to identify who are those bad drivers. So the use case again here is that we want to identify good drivers and the bad drivers, and based on that have some insurance premiums on for the good and the bad drivers. Now think about intuitively. The first step is a use case. The second step, intuitive thinking. That how do we do that is that normally if you could know how someone is driving, not how someone drove a year ago or his past record, but how someone is driving now, then we could actually have this data about the real-time driving, and then based on that we can easily track how these people would be and have some numbers about how good and bad they are driving. So that's intuitively that's a process that everyone would think about it. So and then the third step is quantifiable patterns. Is what we see that there are four basically patterns of driving: speed, acceleration, braking, and mobile usage while driving. So we thought, okay, if we could get these kind of data, then we can quantify. Then we can actually categorize a good and bad driver. So this is a snapshot of the app that we had built, and you can see that we were kind of tracking how people are driving. We were tracking that how long they drove, what is the distance, and how and they gave a score for that. And the fourth step is, okay, once we could get the data, then how do we select the best algorithm? And this is basically those who already are in machine learning would know that it's basically a clustering problem. So you want to group the bad and the good drivers in different things. And what we use is something called self-organizing maps. I don't want to go into details of explaining the SOM because I have a slide on that. But I think I will skip that because this is not to talk about explaining algorithms. But the basic idea here is that quickly walking through that, you have some inputs and you are trying to map the inputs in a 2D space with the output being grouped together. And the way it works is you start with the training data, you calculate something called the Euclidean distance, and then based on the Euclidean distance, you select the best match node, which is, let's say in this case, the yellow one. And then you select all the neighboring nodes around the best match and adjust the weights of the neighboring nodes. And in the end, you end up creating a cluster of similar inputs in similar groups. And so that's basically a clustering algorithm. We could have used a k-means also. So it's not about what algorithm we use, but we tried to use SRM. And the final step is once we have the data and we train the model, one of the challenges that we had is why would someone give the data? Like of course, is all that I said is great. Okay, we can get the data and things, but the question, that challenge that we faced was, in this case, was how do we get the data? I will talk about it tomorrow more, but the basic idea was that, how do you incentivize people to share the data? And we had to do a few things like, we gamified the system. And based on that, we ended up getting a lot of data. We had around 5 million kilometers of driving data. And what we saw that we over a period of few months even, we ended up changing driving behavior. So people were actually end up driving better just because they gamified the whole system. So that's a second use case. The third use case is which I'm working on. It's basically improving customer experience in the banking sector. So banking sector is traditionally an old sector, and there's a lot of improvements that they can do. And just to understand that banks have a lot of data already. So for them, the challenge is not getting the data. For them, the challenge is how do you build products which would end up used by people, right? And the use case that I defined is, how do you predict someone what he needs? Now that's a very interesting use case. That if a bank could know that tomorrow or in a week you want to buy this, or you might want to get a loan, and that's a very valuable information. That's a simple prediction. So here again, the first is the defining the use case. I'll skip this, it's not details, but the second step is basically how do we understand the intuitive thinking. Now, what you would understand that there is there is a pattern in what we do, what we eat, where we go, what we want. So there is a pattern in that. So if we could model that pattern, that how people are behaving in a certain way, then we can actually predict that in the future. So intuitively, that makes sense. Then the third step that there is, once we have the data, and banks have the data, I created a slide of different kinds of algorithms, but let's say that what basically ends up being is, if we have the data that we could model, so we can use two different kinds of algorithms, machine learning algorithms for prediction of the next purchase. One is a word-to-vec, which is a semantic, which kind of builds a model around the semantic relations between the input data. And the second is LSTM, which is a long short-term memory, which is more into storing the memory over longer time and trying to predict, like, say, what could happen in the next 1 month or so. So we have already worked on word2vec, which is kind of creates a short-term prediction, but LSTM is something we're trying to work on, and we need more data to train the LSTM. So what I basically through all of this, I wanted to say that I gave you 3 examples, and I kind of show that there is this focus of like when you're trying to build a real world product, you have to understand the problem you're solving, think intuitively what makes sense, and how do you solve the problem. The third step is you find the right, that quantifiable patterns. What are those patterns, and what are those data that you can gather? The fourth step is you collect to find the best algorithm, which is actually, this is a list of algorithms that I've listed down, which ends up being, these are the 5 kinds of basic neural network algorithms that are normally used. And I kind of showed that what are those cases in which, what kind of quantifiable data and what we want to achieve. And each of those you would know, okay, if this is what we want to achieve, let's say if I want to achieve short-term prediction, then I know I will use a word2vec. If I want to use a long-term prediction, I will use LSTM. Or if I want to classify into groups or something, then I will use the classification. So that's the basic once you select the algorithm, then the fifth step is basically gathering the data. Now, I know it's as the fifth step is the biggest challenge of building a machine learning product, because often the data may not be easily available, or the data may not be there always. And that's what I will perhaps I will talk about tomorrow. So that's basically. I hope this gives you a quick and a brief idea about how can you go about building a product in real world using machine learning. And one of the things that I often say, that the challenge is not the real challenge of machine learning is not coding. So for a lot of young people who come to me and say, hey, I want to be a machine learning engineer, what should I focus on? I say, well, if you are just focusing on building writing a piece of code, then it may not be the best focus, because a piece of code, machine learning is easily to replace, and tomorrow perhaps machines will write a piece of code. So try to think through a point of view as a product. That can you think about from a product point of view, that how do you build those products? What are those things that you can solve, and how do you kind of get the data, all those? This is a book that I wrote, and most of the things that I said today are already in the book. But yeah, if someone is interested to read, they can always go and get it in Amazon. Yeah, tomorrow I will be talking about more on the overcoming the challenges of data and data gathering, and overcoming the challenge of even architectures. How do architecture systems as well as user adoption? So I hope you guys enjoyed it, and I will be interested to feel free to ask me questions if you have any. Difference between machine learning and deep learning. So deep learning is in a machine learning. Machine learning can be done in different ways. So, for example, in a machine learning, you can use statistical modeling methods like Bayesian. You can use naive-Bayes. You can use regression techniques. You can use neural networks, or for example. This I will primarily say these two kind of things: the supervised and let's say the neural networks. Now, even within neural networks, you can use different kinds of neural networks, right? So it could be like word2vec or CNN and things. Now, a deep learning is where you are using a neural network where you have a lot of different layers in the neural network. So in a neural network, you could have, let's say, one hidden layer. You could have 5. You can have 20 hidden layers. So let's say a simple model like word2vec, which is one hidden layer neural network. So that is not a deep learning. A deep learning is where you have, like, say, 20 or 30 hidden layers, and that's a kind of a neural network, and that's where you talk about deep learning. Most use cases don't require a deep learning. Deep learning is mostly used either in speech or in image analysis. So, like for example, in the CNN that we are using, or where we have we are using at least, like, well, it's not deep, but around 15 hidden layers. So that can be considered as a deep learning, right? So it's more about to do with your neural network architecture, and that defines whether it's a deep machine learning trends in future. I don't get what your question is. Is that you're asking me what would be the trends of machine learning in future? If that's what you're asking, then so one of the things that I do is I do talk with, let's say, different stakeholders around the world, and as I said, I was just in Kuwait. Back from there, next week I'm going to speak at BNP Paribas. There's a bank, and I see there's a huge interest, not from the AI people, but from the industries of banking, insurance, energy, to use machine learning in their and solving the problems and optimizing the processes that they have. I'll give you an example. One of the biggest, so I was there in ABK, which is a big Kuwaiti bank, and they said their problem is along queues in the bank branches. So can machine learning help there? And I said, yeah, it can help there by analyzing certain patterns and then optimizing a few things. So itself, machine learning will not do that. What it will do is find a problem, identify the patterns, and so itself, machine learning by itself will not do much. But when you start thinking about the problems and the processes that a bank or insurance company have, and I can go on and speak at least 5 cases that I can talk about where I have worked or I'm working on where the processes are broken, and machine learning can fix those processes. And primarily in these old sectors like banking, insurance, energy, healthcare, these are the sectors that can benefit hugely from using machine learning. But I often say that these are not the most complicated machine learning that we'll be using. Actually, these are most problems of the real world could be solved with the classification, clustering, word to vec, maybe CNN to some extent, not that deep either. So that would be my future trends. What are the risk factors connected with machine learning product development? I think that the biggest risk is now one of the things that the current machine learning algorithms don't have a way to answer why a given output is. So it is basically it's a black box. Think in this way. So these work as a black box. So you are giving an input and having an output. Let's say in a supervised learning, right? So it's training based on the past data input and output. But the machine learning itself, the product doesn't know why the output is like that. So if you want to know a provenance, the provenance is a word. Provenance means that why a given decision was made and what are the reasons for making a given decision. If you want to know the provenance of a decision, that you cannot use machine learning for that. At least not the current algorithms. So that would be one of the big risks, that if you end up building systems where you need to know why a decision was made, then machine learning is not good for those. At least the current algorithms are not. They cannot. It acts as a black box. Machine learning is good to do some prediction with like statistic prediction, right? 90% probability that he will buy this, or 70% of doing that. That's number one risk. The second risk is that trying to solve problems that require 100% accuracy. Machine learning algorithms, the current ones, and I don't know the future, but at least in the next few years, don't have that ability to be 100% accurate. They just don't have, because the way it's being trained is a past data, and there will always be an anomaly. So if you're trying to solve a problem that requires 100% accuracy, don't do that. And that's the case, for example, speech, and like or to some extent autonomous cars. And I say that if you are looking to build a 100% accurate solution, that's not good for using machine learning. And what you really need to do is to combine human and machine intelligence together. So instead of just relying on purely on machine, you combine them together. So autonomous cars is a good example there also, because now the US government says you always have to have a driver behind the wheel. So even if the car is driving, you cannot have a person just not be there. So, and that's a way to solve the problem. So there are always this one person will be there, where you need a human intervention, and you need a human intelligence there to solve it. I hope that answers the question. And let me see what else you have. What are the risk factors? Okay. What are the machine learning solutions for content generation? Well, I think I'm not aware of solutions. I mean, if you're talking about off-the-shelf solutions, I'm not aware of if there are any. But I know there is last year, New York Times started using machine learning algorithms to write articles, news articles, and the algorithm that is normally used is word to vec or LSTM. So normally, why is that? Because when you look at so word to vec is an algorithm that was initially built to predict the next word in a given sentence. Because there is a pattern in that too, right? Like so, and you can potentially train a machine to create those sentences. And LSTM also, because LSTM is a sequence of you can train that every news article or every article has a sequence or content that you're writing. There's a what is the pattern that would create that engaging content. So once you train a machine like an LSTM with past data that shows that there is this kind of patterns of data creates the engagement more, you can generate that. The machine can keep on generating, because you don't necessarily need original content every time. But if you are looking to build something thoughtful or really editorial kind of thing, that machines have not that capability or the intelligence to build it. So again, content would be two types. One of the content is if you're trying to build repeat contents, like kind of similar contents, and 90% of the content is repeat content. So that you can use machine learning. And I don't know if there are solutions already, but I'm sure there are companies working on them, and it's if not already there. But in terms of original content, in terms of editorials or thought leadership, that's very difficult, and machines will not be able to do that, at least in the foreseeable future. Let me see what else. Machine learning app development for predictive marketing. I'm not sure what is the question. What do you mean by machine learning app development for predictive marketing? I will skip that question. So if you could explain me later on, I will go to that. Explain prior probability, likelihood, and marginal likelihood in context of explain prior probability, likelihood, and marginal likelihood. So I will skip this question primarily because I think in this case I haven't worked on naive Bayes. I do know what you're talking about, but this is not a mathematical talk. So I wanted to keep this mostly with respect to the the real world problems and how do you build problem solutions. So this kind of mathematical or algorithmic questions, I'll skip it because that's not within the context of this talk. What is data normalization and why do we need it? Well, again, the same type of question that I said. I mean, these are, you can easily Google it and find these questions answers. But why do we need to normalize data? Is because basically because you would have different data sources, different kind of not only different. Like for example, in the real world case, I'll give you an example to that. Is we are training a data based on let's say the age of a user, then what is his expenditure, or what he has been, where he lives, for example. Now we need to normalize the data just to make sure that not one of the inputs has a higher weight than the other, and so that they are all weighted equally, kind of thing. So that's one of the reasons we would do a data normalization. How do you handle missing or corrupted data in a data set? I will answer that question tomorrow because it's very hard to answer that one way. And in short, that I will say that the way to deal with the missing or a corrupted data, well, corrupted data is difficult to deal with because if the data is bad, then of course your model will end up being bad. So you have to clean the data. So if you already know the data is corrupted, then better clean it. The missing data is a more tricky problem, and I did, in the book I do talk about there are 3 ways you can deal with that. But I'll skip that question for tomorrow. I will remember to touch upon that tomorrow, talking about missing data. Okay, how do you go about doing a exploratory data analysis? I'm not very sure what do you want to mean by exploratory data analysis. I would perhaps need to Google it and understand it. I don't know really. I haven't heard this word, so you have to explain me. Sorry for that. How do you know which machine learning model you should use? Well, again, that is a tricky one, and not tricky one, but I showed you a slide with I put you those 5 neural networks and what are the conditions in which you would be using and which you would not be using. So you could kind of know that, let's say, what to work is a prediction, short-term prediction, and where the data is and you want to build a schematic relations for that. So there are already texts out there where kind of, and this is what the slide that I spoke about. In the slide, you can already read that, but that's specifically for neural networks. But there are also regression and other things that when to use this, and if so there are material out there that you can easily Google and find them out, that which algorithm to be used at what cases. Okay, what are the different algorithmic techniques in machine learning? Different algorithm techniques in machine learning. I'm also not sure what you mean by algorithm techniques, but if you are asking me about what are the different algorithms of machine learning, then as I said, there are you could basically classify. I mean, there are different ways you can classify this. You can classify machine learning, but the way I would define is think in the way of supervised learning, unsupervised learning, and reinforcement learning. And then within supervised learning, you can use either neural networks, or you can use naive Bayes, or you can in unsupervised learning you can use a k-means, or you can use a clustering like SOM, which is a neural network classification. Or you have reinforcement learning. I would not. I mean, reinforcement learning is I did write about it. It's a more complicated than that, and I think most real world problems doesn't use reinforcement learning. Reinforcement learning is primarily used for currently in a very closed environment where you could control the environment, because the learning is based on the feedback that you get from the environment, and it would work in things like teaching a robot to play ping pong, or teaching a robot to play chess, or play a Go. So basically, I would classify machine learning algorithms in 3 these kind of main learning algorithms, and then each of those have different things. what is overfitting in machine learning? Well, okay. Again, these technical questions I would normally would have avoided, but basically, when you overfitting, as the word basically means, that in the neural network you're overfit the neural network. That means that the neural network is when you have, let's say, a too less amount of data, and you have a like a more deeper neural network. So the model that you have built ends up being too much adapted to the data. So it's basically works only on the training data. So and there are ways to deal with that. How do you fix the overfitting? But in a way, what you mean is that your data is your model is too much fit. Too much fit in a way is not good, because you want to have this flexibility where when you have a test data or a real world data, that it actually gives you the right output, not just works on the training data. So that's overfitting. Different use cases in machine learning algorithm can be. I mean, that's a big question, and I mean, as I gave you this thing, that what I showed you those 5 points, that one of those 5 points that you define a use case of machine learning is distributed data, where you have the data is distributed, the knowledge is you have high quantifiable patterns, you have high human error, and you have low intuitive patterns of human behavior, where you require low intuitive patterns from the human. And these are the conditions that you have to look. And there are a lot of such cases. I mean, there's full of use cases in any sector that you take, as I said, that where you could see that there is high human error. There's a lot of data that you can gather, and you can use the data to, and these are high quantifiable patterns. Like, I give you one example of what queues in a bank or in an insurance company, how they calculate premiums, or in a healthcare system detecting or identifying diseases. There's a pattern in that. Once you realize that most of the world around us there are patterns. Once you realize that fact, then you know that there are use cases, full of use cases. And most of us behave with those patterns. So the machine could be trained with the patterns. The only thing to remember, that if you're trying to build a solution to replace humans that would make 100% accuracy, then you cannot expect that. But if you are expecting to where if it's 70% accurate, 80% accurate, it's okay. It's not a life and death issue. So in a healthcare system, if you know a system where it would identify it will say, okay, there's a 90% chance of this disease. That will help the process and optimize the process. And a doctor can actually see that. So these kind of use cases to think about it, where you are not just replacing human, you're trying to bring intelligence or machine intelligence to the human process with those parameters that I said. What are the 5 popular algorithms for machine learning? Popular, I don't know what are the popular words would be, but I mean, I have used LSTM, word-to-vec, classification, clustering. In clustering, again, k-means is quite used. Regression normally is used a lot in the banks. In the past, have been used a lot. Naive-Bayes is normally not used. I have never used Naive-Bayes, so I mean, I don't know a lot about it. CNN is used a lot. CNN is used a lot for image analysis. So I'll basically, if I have to say top 5 that I have worked a lot with, are word-to-vec, LSTM, a classifier, neural network classifier. One would be regression. Would be one. Regression is basically on finding the relation between different data patterns, which is used a lot in especially banking insurance sector, where you have a data. And the 5th will be CNN. How to prepare for the future of machine learning in business? How to prepare? I don't know how to. I don't know what you mean by prepare. I mean, there are different roles that as machine learning will be integral part of product development, right? So and your role can be in different ways. You don't have to be a machine learning coder to be part of a machine learning thing. I mean, coding, I really sincerely believe coding is the simplest part of machine learning, and specifically with Keras and TensorFlow and those kind of libraries coming up. I mean, they will be full of coders. Coding is not the key aspect here. The key aspect is intuitive thinking and how do you build products, and product thinking, which has always been the key. So where to apply, how to apply, what algorithm to use, how to deal with the missing data. I mean, that's a key aspect. And it's not as simple as just, okay, I write a code and get a data. And so these kind of thinking, structurally thinking and product thinking would be, I think, is the key aspect of building machine learning products. Okay, what is the difference between supervised and unsupervised learning? Okay, again, very quickly I will answer that question. I mean, these are things you can easily find in Google, but supervised learning is where you have an input and output data already. So you already have a, how will you say, tagged data where you already know the input and the output, and you're training a machine based on to learn those data from the past input and output. In the unsupervised learning, you don't have the input and output. You only have like a data, like in our case with the driving data, and we don't know who is a good and bad driver. We just know we have some data, and we just want to find some patterns within the data that we have. So it could be grouping them in different forms, like clustering, or finding relations in the data. So that's unsupervised learning. What machine learning algorithms can be considered as among the best? I don't know what is the best means. I mean, there is no concept of best in a machine learning algorithm. I mean, different machine learning algorithms are used in different purposes, and they have all different uses. So there is no like best algorithm. What is the difference between a cost function and a loss function in the machine learning? Again, I mean, as I said to you, that I would avoid answering these kind of more technical questions, because these are, you can easily go and find them out in the Google. But typically, what I'll like, so in what I would suggest is that if you have more technical questions, I can do a more technical talk later on where I can answer those more technical questions. But today I basically wanted to talk more about the real world products and how do you want to build those real world products. So I think that's good enough for me. And again, I mean, I'm so sorry to avoid some of those questions, primarily because I think that you guys can easily go and find those questions in answers to those. Is that good enough? Anything else? If not, I think that's it's almost an hour, right? So
thanks for your wonderful session. It's very, very informative. I hope the audience also gets some insights on machine learning. Thanks for your wonderful presentation to us.